at the end of your experiment, you went through and you picked out molecules based on how many atoms there were attached to the carbon. Okay? So, for instance, let me make a little model here. You made the models of, let's do CO2. How many bonds does carbon make? 4? Carbon makes 4 bonds. So you've got 4 bonds to make, but only 2 O's to attach to. Then what do those bonds both have to be like? They both have to be double bonds. Okay? So we have a carbon, a central atom, that's attached to just 2 other atoms. CO2 looks like this. Okay. Like that. Okay. So I'm making all 4 bonds to the carbon. Each of the O's is making 2 bonds. Structure looks like that. And I'm going to draw those O's straight out from each other. Okay. That's what the model sort of tells us. But if you think about it, that would make sense, because this O is going to want to be as far away from that O, just so things will spread themselves out around that carbon. What else do I need on this structure here, by the way? Dots around the O's. Now the dots on the outer atoms, they actually don't change the shape of the molecule. It's really just the interior atom that we're looking at. And if there are multiple interior atoms, we can look at them one at a time. Okay? But we call this linear because it's in a line, okay? Pretty much straight out from the left to the right. Another one was HCN. That's also linear. H can only make a single bond. So what kind of bond has to be between C and N? For carbon to make 4 bonds, right? That's got to be a triple bond. And then we need dots on the end. Okay? So we call that linear because it's like a line. Right? Makes sense. Anybody remember what the model for water looked like, though? It was an O with 2 H's, but those H's didn't go straight out. If you made your model, they were kind of bent to the side, like this. Okay? And there's a really good reason for that. We draw the water molecule like that. If we're drawing it with its correct shape, we're not going to have those 2 H's off on either side, because what else is there on the central atom that I haven't drawn yet? We need dots to get our octet on oxygen. Okay? Notice here, we still have 2 atoms attached to the central atom, but the difference is lone pairs. Lone pairs are pairs of dots, okay? Unshared electrons. And if we have dots on a central atom, a pair of dots takes up just as much space as a bond. Okay? So what you're actually not seeing in this model is a pair of dots here and a pair of dots there. Okay? They each take up their own space. Yeah. No, because how many electrons does hydrogen like to have? Hydrogen starts with 1 electron, but it's just in that first row, so it wants to be like helium, which has 2. So hydrogen's 1 electron is in here. It paired with 1 electron from the oxygen, so hydrogen's 2 electrons are right there, so it's full already. Okay? So that's the... Everything else has the octet rule. What do we call that for hydrogen, though? Duet rule? Yeah, that H just gets 2 electrons. Okay? So dots on a central atom will push the other bonds towards each other because those dots need to take up their own space. Okay? So sometimes what we like to do is draw big balloons around them, just as a reminder. But it's those lone pairs take up space just like a bond. Okay. You didn't identify any bent atoms in that last part of the lab because carbon doesn't have dots on it. Okay? Carbon makes 4 bonds. That gets it up to its octet. Okay? So no matter how we have carbon bonded, it's not going to have dots. But oxygen will. An oxygen with 2 bonds will look like that. So in fact, always draw O with 2 single bonds as bent. Like that. Okay, that's going to help us. The model kits already do that because the holes are at an angle to each other like that. But when you're drawing structures, if you're drawing 2 single bonds to an O, draw them bent like that. Don't draw them straight across from each other. Right. All right. We've done this one a couple of other times. Let me just put it together quick. It's my green back here. CH2O. Okay. Carbon makes how many bonds? Carbon makes 4 bonds. The CH bonds have to be what? The CH bonds have to be just regular single bonds, okay? Because H only can fit 2 electrons. But that means the CO bond is what? CO bond has to be a double bond, okay? So here is what that structure should look like. I've got 2 different size sticks in here. That's a problem. Okay. So it's like that. I don't know why that's twisted a little bit. There we go. Okay. That's what CH2O looks like in the model form. We draw double bond there, single bond there, dots on the O's. That's the other way O can be, right? O will have 2 bonds. They could be 2 single bonds and bent, like up there, or they could be two bonds together to the same atom as a double bond. Okay? But now, look at this carbon. That carbon is attached to 3 atoms, but there are no lone pairs on that central atom. So this shape is called trigonal planar. Trigonal means 3 atoms attached. What does planar mean? What is in math or something, what is a plane? Plane is something that's totally flat, like a sheet of paper, something like that. So if you look at this from the side, okay, all of those atoms fall within, I'm holding this. All of those atoms fall within the same plane, okay, like that. Another way of thinking that is if you set this molecule down, it would sit flat on the table. Okay? So trigonal planar, 3 atoms, but flat. Okay? And they're spread out. Right. Okay. Spread out around that central atom. Flat like a sheet of paper. Okay? That's what trigonal planar means. But a different atom does something a little different. What's the atom that makes 3 bonds? Carbon makes 4. We've got O's making 2. Nitrogen makes 3. Okay, so you take one of my nitrogens. We've drawn and made NH3 several times already, but you'll notice something different about this model. I did not get a very good model kit. Okay. If you look at it from the top, it sort of looks the same shape as that other one, but if you look at it from the side, this is no longer planar. correct? Because if that's N, and I've got 3 H's there, what is it that's right here taking up its own space, pushing these bonds closer to each other? What lives right in this section right here that I'm holding? What is that? Yeah. In NH3, we've got a pair of electrons. Oops. Don't start Excel. That's why I had you draw NH3 sort of from the side, like that. Because it has a pair of electrons that take up space. Sometimes we draw the little balloon around them. Okay. Still trigonal because it's 3 atoms attached to N, but not planar anymore. Trigonal pyramidal because it looks like a little pyramid. Okay. It's like a pyramid or like a tripod, I like to say. Okay. The fact that we have this lone pair, the lone pair repels those bonds. Okay. The bonds are just pairs of electrons themselves, and electrons repel each other. So if we've got a pair of electrons here taking up their own space, then the other things will sort of spread out, okay, and be kind of squished together a little more. Does that make sense? So what is the big difference to look for when you're telling if something is trigonal planar versus trigonal pyramidal? What is the key thing that makes those two different? The lone pairs on the central atom. Okay? Now look at my descriptions up there. Trigonal planar is 3 atoms on the central atom, but no lone pairs on the central atom. Trigonal pyramidal, 3 atoms on the central atom, but yes, lone pairs on the central atom. Okay? In this case, it's just one lone pair. We count them as pairs, so it's just one lone pair taking up its space. Does that make sense? That's a good way to think of it, but make sure you can sort of have that little picture in your head. It's not going to work well to try to just memorize what these are called and how many of what there is. Okay? All of these things are just naturally spreading themselves out around the center of an atom. So you think of just how many groups of things are taking up space on the central atom, and they sort of spread themselves out. All right. The times that you made carbon, and here I'm not going to remake it. Let's just pretend that this is black. Okay? When you had carbon with 4 bonds, they formed this shape. Notice it was not up, down, left, right. It was this shape called a tetrahedron. That's what the tetrahedral shape does. And it works best to draw 1 up and 3 sort of downish. Okay. That will happen when we have 4 atoms attached to the central atom. Okay. So try to draw this. I mean, it doesn't have to be perfect, but if you make some sort of attempt at drawing it in perspective like that, in fact, as long as you have no 2 straight across from each other, it'll work out. So try not to draw this one going straight down. That's why I draw that one off to the side, this front one off to the side a little bit to have a little perspective from it. But you can see in the actual 3D model, there are no 2 that are straight across from each other. Okay? They're all at this angle. Right? No matter which 2 you pick, they're at that angle to each other. Okay? So another way of organizing this together, okay, is by electron groups. Okay? And the mastering chemistry is going to ask you about electron groups. An electron group is just a bond of any type or a lone pair. Okay? Essentially something that takes up space on the central atom. So for it to be linear, how many things are there taking up space on the central atom on both of these? What do you think? This is something, this double bond to O, that's one thing that's taking up space on the central atom, right? and that's another thing. So for it to be linear, it's how many electron groups. You can sort of draw them like that. There's one, there's another. Right? There and there. Okay. Go down to this one right here, trigonal planar. How many electron groups is that? Yeah, that's 3, 2, 3. Okay. And then all of the other ones, the bent one, the trigonal pyramidal, and the tetrahedral, they all have how many electron groups? They all have 4 electron groups. Right? If we do something like that. Okay. So with this one model right here, I've got 4 bonds. But if instead of a bond, instead of one of these bonds, I have one pair of electrons, now I'm trigonal pyramidal. Okay? We started tetrahedral, like CH4, pretend that's a carbon. But now, if we replace one of those with a pair of electrons taking up that same space, that's trigonal pyramidal, okay? Like NH3. Okay? What if I replace another one with another pair of electrons? What is this shape called? This is bent. This is like water. Okay? Water has 2 lone pairs of electrons. Okay? And if you look at it like this, one will be pointing out towards you, right here, and one will be pointing back the other way, right here. Okay? So all of those ones have 4 electron groups, including water, right here. If we count those ones as well, 2, 3, 4. So an electron group is just basically something that takes up space on the central atom. It could be any kind of bond, single, double, or triple. That's an electron group. Or it could be a pair of electrons. Okay? So the basic shapes are really just linear, trigonal planar, or tetrahedral. Okay? But replacing any of those with pairs of electrons gets you those other ones too. So just another way to think of it. So we're going to come back to these, but